Okay, here we go. So we can graph the inequalities on a number line. This helps me, at least, to visually see how that interval is going to work. So I didn't do any on that last slide, but it's still doable. Okay, so we know if we have just the greater than or, sorry, that's less than or greater than symbols, we're going to end up with open circles on the graph. And you're going to have to distinguish between the two on the assignment. If, for some reason, it's equal to, with the inequality, it'll be closed circled. So mathematically, what this communicates, an open circle says that that value where there's an open circle is not included, or it would make the original inequality false. Okay, but if it were a closed circle, mathematically that communicates that that value would make the original inequality true. But we usually only use points to indicate that we're transitioning from falsefulness to truthfulness or the other way around. So this is the way that I like to look at it. Some students do this a little different. You can have your own way to do it. Doesn't matter to me. But I see, does the inequality eat the letter or the variable? If it does, then I know that line goes to the right. If it does not eat the letter, it goes to the left. Okay? And then if I'm doing this by hand, I'll have to put 3 numbers on the number line. We'll see if that's necessary. I say that it eats the letter because a lot of students relate that to the alligator stuff. For me, it's a shallagate, but that's different. Now remember, with these inequalities, you do want to notice if there's a negative coefficient, because if there is, we're going to have to use a principle of equality with multiplication or division. And if we ever use a multiplication or division principle of equality with a negative, then it will flip the sign. This one, of course, is positive, so we're not concerned about that right now. And I know I can solve this inequality with one principle of equality, because I would just like this to be y compared to some value. And so to make that, it's really a phantom 1y, I'd have to divide both sides by 9. So 9 divided by 9, there's my phantom 1. 27 divided by 9 is 3. And again, we did not divide here both sides by a negative, so the inequality remains the same. So that's my inequality. And so we got the inequality, so the graph. I got the graph here at the bottom. What I like to do is I like to put, I like more room actually, so let's start with that. But from here, I like to put the value we're comparing there, 3. I like to put it right in the middle. And then just one value to the left, that'd be 2. And then this is positive, so it gets bigger to the right. If you want to be really thorough, it may be good to know where 0 is. And I know 0 is somewhere to the left of 3. Some students get mad at me, though, when I do this, because now there's not proportionality between the values. But I'm not the kind of math person that cares. So if that's you, just give yourself some more space. It doesn't bother me. Okay, so I'm comparing there in red, y is less than 3. So since it's just less than, it cannot equal 3. At 3 in the middle there, I've got to put an open circle, which communicates that if you were to use 3 in that inequality, it would be false, because 3 is not less than 3. Okay, that's fine. Now I look and I see, does the inequality eat the letter y in this case? It does not, which means that the line will go to the left. Now for me, that's good enough because I'm doing this by hand. On the assignment, I believe you'd have to click an open circle on 3, and then from there you have to drag it, but you have to drag it all the way to the end of the line until you see an arrow there. If you do not see an arrow, it'll mark it incorrect. So now it's really a short distance here to get to the interval, which I'm going to show just because, I don't know, I feel like I should. So this one goes all the way to negative infinity, which is never included. It stops at 3, which is also not included. Boom, that would be the interval.